I'm super excited, Lika, to talk to you.
And we had over 80 people registered, so we should have...
Wowza. Very cool. Big attendance.
Oh, you've put the pressure. You have been advertising. My goodness.
Mm-hmm.
Can you see the participants list, Lika?
No, how do I do that?
On the bottom, on my screen, and I'm the host, on the bottom it says participants.
I see 10 attendees.
And you can click on that and see who's here.
Oh, wow. Lots of my friends. Jesus, they are all senior people. What are they doing here? Seriously. Cool. No, I'm not going to distract myself. Oh my God, I miss Abby.
Abby, hello. The finest program that Abby is running is phenomenal. I have to shout out to the vision for finest. Okay, what I will do, I think we're going to wait for a couple of more minutes. We have more than 80 people signing up. Welcome, everybody. I see lots of friends signing up. And in a bit, I'm going to share my screen. And so, Lika, I will just give a little overview about SHIELD and what the SHIELD webinar is, and then we will start.
Okay. I didn't know whether we were live, so I just muted myself.
Yeah. Hey, I saw Nancy Crooker, Olga, just signing up. Haven't seen you guys for a while. So great to see you guys. Okay.
Good.
Do you see only the first
Yep.
slide?
Yes.
Okay, great. Okay, so welcome everybody. This is another installment of our SHIELD webinars that we started a couple of years ago as part of SHIELD. And the idea behind it was to have a safe space that is informal, that we can hear the personal trajectory of some of the leaders in our field and hear how they got to where they got and what are the challenges that they faced and how they dealt with that as in a very informal conversation. And we will open up later on for questions so people can ask Lika questions. And I'm the director of SHIELD, and John Richardson is a program manager, and he's at MIT. And so just to introduce what SHIELD is about, I think most of you guys know what SHIELD is, but the theme of SHIELD deal with astrospheres. And I always like to show this slide just to remind our astronomer friends that when you look up in the sky, you see a bunch of stars. They're not just naked structures, but they're all surrounded by an envelope that we call astrosphere. For solar-like stars, like the sun, that Lika is going to talk more, the wind is very rarefied, so it's very hard to see this cloth around the stars. But they're all there. Those are real images from NASA, several missions that detected the astrospheres around more massive stars. The other piece that is very interesting and worth emphasizing that we have life, of course, on planet Earth. We are looking for other life around other planets. And so we think that the development of life on planet Earth had to do with the fact that we live within this specific astrosphere. So we would like to understand the heliosphere as the only case that we know of a habitable astrosphere. And what is unique about the heliosphere that made the life develop on planet Earth. And to drive this message home, we created a movie within SHIELD. You can go to our website shown here on the bottom and download the movie. And it shows planet Earth and all the other planets embedded within this large structure that is shown here, that is a heliosphere that envelop us and protect us now. And maybe in the past, the heliosphere didn't have this shape and didn't protected us. So this is one aspect that we're interested in SHIELD to also understand the development of the heliosphere with time. SHIELD stand for solar wind with hydrogen ion charge exchange and large-scale dynamics. And the vision of these drive centers is one of 3 drive centers that was funded by NASA as a center that require several opinions and several expertise to tackle a science question where we can achieve a breakthrough. And the vision for SHIELD was to create a digital twin of the heliosphere. And in that, we try to understand the basic physical processes that drive the heliosphere. And there are lots of institutions, not just domestic, but also international, that are part of this effort. We created this big mosaic. Again, you can check our website that kind of summarize all the different theoretical and data aspects that we're trying to tackle. And I'm not going to go all the science of SHIELD. You can check out our website. I also want to bring up the very important aspect of SHIELD is trying to create a diverse community and bring diverse voices to the table to be able to tackle these important science questions. So we have lots of activities, and the SHIELD webinar is just one aspect of it. And one other aspect that I will mention really quickly, if you're interested, reach out to shieldoutreach@bo.edu or to the Broadening Impact team. We had in our website a series of testimonials of younger people telling their own trajectory. So it's almost a counterpoint of what Lika is going to talk about, already established leaders in the field, but other students that are just starting now and how they got to where they got. And we called it, you can be what you can see. So we're very interested people, even outside of SHIELD, to helping out and creating this mosaic of voices. We will have the next SHIELD webinar will be the Queer Eye for Space Science in January 19, 2 p.m. And will be a panel with myself and Edgar and Jaye talking about what queer folks bring as a new view of when they do science. We also have a monthly coffee chat. The next one will be on Friday, December 1. This is also open to outside people from SHIELD. And here are the links, both from the webinars, both of the coffee chat. And the coffee chat are primarily for early career and emerging scientists, where PIs are not allowed and more senior people are not allowed. So it's a safe space, again, to discuss some aspects of being a researcher. So here is just a final slide to summarize all our activities. We have a new Friends of SHIELD newsletter. Please sign up. Here is a QR code here. And today I have the immense pleasure to welcome Dr. Madhulika Guhathakurta. In this seminar, we are all living stars. And before I introduce her, I just wanted to bring a personal note. Here is me on the bottom right. My mouse is hovering. My son was in my belly at the time. And this was a presidential early career award that Lika nominated me back in 2007. And I'm so, so very grateful for her vision and for her mentorship. She is a living mentor for me. I reached out to her in a time that was very challenging. And, you know, I didn't know that. And a year later, I got this award. So I'm super grateful to Lika. So Madhulika was born in Calcutta in West Bengali. She's going to tell all about that. She studied her bachelor in University of Delhi. She got her PhD in University of Denver. She had an illustrious career. One of the leading things that she did was to lead the NASA Living with a Star. I remember that time was incredible, the vision, the drive. She also led the Van Allen probes and the stereo missions. Previously, she was a program scientist on Spartan missions, and she's been an overall a drive for vision and for programs within NASA. And she also is a very well-known scientist with more than 100 publications. She got the NASA lead scientist of the solar eclipse in 2017. So I am going to let Lika tell us how she got to where she got and her personal trajectory. I'm going to stop sharing and let you take the stage. Now we can see and yeah, if you go right. Yeah, perfect. Now it's perfect.
Thank you so much. Marav, it's like going back to old times. It's a community of sisterhood. I don't know how else to describe, even in a relatively sparsely sampled women in our field. We have connected in a number of ways, and I kind of just want to give example of the previous two speakers. Sherilyn Morrow, we go back decades because we were graduate students together at HAO, and then Sarah Gibson. These are friends, colleagues, all of it. So I am going to stop my personal video because I live on a mountaintop in Boulder anymore, and bandwidth is somewhat limited. So I will bring back myself. Can you hear me okay?
Yes, perfect.
Okay, so, I have 6 solar cycles worth of stories to tell, and I can only cover so much in this short amount of time. So I did pick and choose, and there are all kinds of trajectories, that require its own fun discussion. So first of all, facts, figures, charts, they are boring. They have always been boring to me, especially, when we are talking about something as cool as the universe or my own personal life, right? So I will take poetic liberty to utilize as much as possible pictures, cartoon, poems, songs to give this talk if time permits. And so talking about poetry, very, very close to my heart, I'd like to recite this poem by Walter Whitman, because it reflects basically my sentiment. And this is When I Heard the Learned Astronomer. When I heard the learned astronomer, when the proofs, the figures were ranged in columns before me, when I was shown the charts and diagrams to add, divide, and measure them. When I, sitting, heard the astronomer, where he lectured with much applause in the lecture room, how soon, unaccountable, I became tired and sick, till rising and gliding away, I wandered off by myself in the mystical moist night air, and from time to time looked up in perfect silence at the stars. This has been the case with presenting our thoughts on something, as I said, so expensive as one's life's journey. So let's not confine ourselves to facts or figures, and instead, let me tell a story. And of course, every story begins with a question. Where have we come from? Where do we go when we die? Where indeed? A question humankind still ponders. Big agencies like NASA create programs around it. These are basically tough questions. These are questions that humankind have asked for eternity. When I was very young in Kolkata, I used to watch the night sky. And as I looked at the stars, I had the same question at a tender age of 5 or 6. And I asked my father. Now, my father was a banker, but he was also a mathematician and a poet. He didn't shut me out with my question. Instead, he gave me an example of a circle. He said, look at a circle. Can you tell me where the beginning or end is? So my question was answered with another question. But through my formative years, I came to notice and learn a few things about life in general, which helped me understand better my father's point. From the very beginning, I think I came to realize basically a simple truth. It is our biological wiring to exist and then not. Through our lives, we work, play, love, build homes, and then one day disband and return to the stars that once made us. I realized this quite early on, and it was then that I made it my mission to understand the stars that we come from and we shall return to. Even at a young age of 13 back home in India, I had to argue with my father to let me pursue science track as opposed to what he thought would be good for me. I used to paint, I used to eloquate, I used to sing, and he thought I should do fine arts with higher math because I was good in math. And that is perhaps my first pivot. Pretty deep stuff. Look at the iconic picture, the pale blue dot. Who hasn't been moved by that? Photograph was captured by the Voyager 1, courtesy NASA JPL. Now, this deserves a recitation of another poem, and you might get tired of this. A Brave and Startling Truth by Maya Angelou. We, these people on a small and lonely planet, traveling through casual space, past aloof stars, across the way of indifferent suns, to a destination where all signs tell us it is possible and imperative that we learn a brave and startling truth. It is important to share at this point that in the Sun-Earth Connection division, which was named Sun-Earth Connection till 2005, that I was the first Voyager program scientist. And it would be a stretch to say, but I might be a NASA program scientist who's had the maximum number of missions under her belt, or his belt, anybody's belt, in the one magnetic solar cycle I have spent at NASA headquarters. These are just little tidbits. So I understood that we came from the stars, and to the stars we return. But my curiosity about our existence was really unbridled, and hundreds of questions were squeezing together in my young mind, much like the atoms of elements squeezing together in dust clouds, thus undergoing fusion and birthing a star. How are we related to the stars? A star's life is long compared to that of a human, but we can see the stages of stellar birth, aging, and death in the heavens. They follow a pattern similar to many of the life cycles we see here on Earth. Sometimes we are binary in our thinking. Maybe very often we are. Either we are superior to nature or we are inferior to it. That's how we think. And I came to understand that we are neither. Our place in the cosmic order is not something that is separate from nature, but is an integral part of it. The human body contains about 20 different elements, mostly made inside ancient stars. The main 4 are, we all know, oxygen, carbon, hydrogen, nitrogen. For every atom belonging to me as good belongs to you. Remember? So stars hold the answer to our existence. And the only star that can help us answer these questions, the only one which is near us and gives us the opportunity to ask these questions in the first place, is our very own sun. So, I was going to get my answer somewhere. It would be studying the sun. My story might sound like a cliche. It revolves around the sun. But isn't that true for all of us? What is a birthday after all? Another revolution of a person on planet Earth around the sun. So these as aloof astronomical objects basically attracted me, and falling prey to their immense gravity, I made a career out of stars to find my answers. And this is still in my early stage. And thus began my journey into heliophysics, which wasn't a word at that time. And so in graduate school, I chose to study the sun, only star we can study in great detail. After acquiring a bachelor's degree in physics, a master's degree in astrophysics, an MPhil in cosmology, yes, I have spent a long time in graduate school. I left the United States of America at a tender age of 23 to do my PhD. This is a pivot point. This is an entirely different story. I wasn't planning to come to US at all, but something happened. I wrote my dissertation on the solar corona of the sun's outermost atmosphere. So this is a picture from my master's days. This is a clique of 5 women friends. In my master's days in Delhi, there were 100 students, of which 50 were women. Can you believe that? And I felt no discrimination, even though I achieved better grades than most men. I was trying to run away from the men, actually. And, then I came to US, and here is the next picture, which is another pivot point in my journey. Never imagined I would marry an American from the Midwest, but that happened at the DU Chapel in Denver. And I'd say that the Midwesterners perhaps are the best. Now, this is kind of only picture from my thesis. This is kind of interesting because, this picture that you see on the right-hand side is the first ever X-ray, XUV image of the sun with the corona of 1988, taken by Dick Fisher from Philippines. And this is the first composite, and this is the first picture of my thesis. This was such a novel thing that it was actually in Time magazine. I forget, either a centerfold or some page. This was amazing. Today, of course, we see dime a dozen pictures, right, of the insert of EUV, X-ray, and the corona, not from eclipse, but from coronagraphs, our missions. Now, here is an interesting story. My life cycle is kind of the life cycle of this eclipse also. So 1988, I didn't see the eclipse, but that forms a big chunk of my thesis. And 18 years later, I went to Libya, 2006, to lead on behalf of the State Department an eclipse expedition. And 18 years follow on to that, 2024, is the next eclipse, 36 years. Every 18 years plus some months is called a Saros cycle. So in my career, I'm witnessing 3 Saros cycles. So, well, let's talk about star stuff for real. Two-body problem, another pivot point. In 93, I joined NASA, Goddard Space Flight Center as an astrophysicist. And, all kinds of cool things happen. The unthinkable imagery and findings that we witness every day at NASA, it really changes a person. It changed me. And so, I'm maturing as a scientist at this point. As the project scientist on 5 Spartan 201 mission, which went up on space shuttle, 5 different space shuttle. John Glenn was our mission specialist for the last one in 1998 to study the solar corona in white light and UV radiation. Now, this is kind of, I'm showing this because this is important. I utilized the Spartan data and brought together the Ulysses community. You know, the solar physics community didn't talk to the heliospheric community. As far as I know, I held the first workshop between this community in 1994. And I think this changed history subsequently at NASA headquarters, but maybe, and remind me when I get to that. So from all this knowledge and inspiration, I understood that learning about our sun would not only help us contextualize our existence, but also help to continue our existence into the future. And you of course have the question, how? Well, you actually know the answer, but I'm going to show this video because it's there, utilizing artificial intelligence, kind of how we are doing some level of prediction, utilizing the vast amount of data we have. Just like on Earth, hurricanes and snowstorms, the sun also produces storms, flares, coronal mass ejections, and all sorts of other phenomena. Except they consist of charged particles, magnetic field, radiation, entirely different. And our technology has become very dependent on sun's wind. So 100 years ago, technology was too primitive to be disrupted by space weather. But today we rely on countless devices that are vulnerable to a storm, and therefore we have to pay attention to it. Hence, I focused on the sun and worked on some incredible missions, met incredible personalities, and set off on my journey to understand the sun as much as we could. And talking about important personalities, real luminaries and stars. This is with Robert Redford, who lent his voice to Cosmic Collisions. It's a planetarium show at American Museum of Natural History that I co-sponsored. Launch of first mission of Living with a Star, 2010, the Hubble for the Sun. Now, think about it. Living with a Star was a big NASA program that was fueled by science only for the first 10 years of its life, because SDO launched in 2010 and Living with a Star started in 2000. This is quite remarkable that science can carry us forward. This is addressing the UN on International Year 2007, follow on to International Geophysical Year in 1957, that we are really in the era of the heliosphere and heliophysics. The picture on the right is actually reading the space weather statement at UN Copious in 2013, where I made space weather a permanent agenda item. Hence, from all of this, a brand new branch of physics appears around 2006 timeframe. So I understood the importance of space weather, collaborated with fellow physicists to form an entirely new branch of physics, heliophysics. And heliophysics is old and new. Heliophysics is the integration of all our disciplines that we were practicing separately before. And you know what I call myself? A heliophysics, she who studies heliophysics. I hope this word would catch on from here. And this is, you all know what is heliophysics. It is the study of the domain defined by the sun. The heliosphere, just like astrophysics, is the study of the physical domain defined by stars. And everything is included in it. Now, heliophysics wouldn't be heliophysics if we didn't teach people heliophysics. And to teach people, we need textbooks. And we needed to create these textbooks. Heliophysics Summer School started actually in 2007. And the two principal deans, George Sisko and Karl Schreiber, if they had not agreed to be the deans of the summer school, I doubt that I have pushed forward with this. These are all sort of career trajectories for all of us, how things actually evolve. This is quite amazing. So this is new science needs new scientists. So we started creating, graduate fellowship program after the pioneering interdisciplinary scientist, Jack Eddy. We do Heliophysics summer school. We continue to develop material for textbooks, and presently we have 5 textbooks. The first 3 are the basic core heliophysics. The 4th volume is like comparative heliophysics. And the 5th one is online for really space weather because it is so new. And as you can see, this gives you a picture basically of the whole heliophysics life cycle, from attending summer school to being a Jack Eddy Fellow to coming back as a lecturer in there. And the heliophysics textbooks give academic form to this new discipline. Now, there have been many missions, Solar Dynamics Observatory to give us the close-up activity on the sun, Van Allen probes give us a view of hazardous energetic particles trapped in Earth's radiation belts. Stereo gave us the first 3D view of our sun. And there is Parker Solar Probe just going to touch the sun. It already has and going to get a little closer. And recently launched Solar Orbiter mission, collaboration with European Space Agency, that's going to give us a better glimpse of the poles. And then there are many other missions that are really revolutionizing our understanding of how the sun shapes space weather in the solar system into outer heliosphere that Marav is conducting. Lack of women in STEAM, I love STEAM, actually. I like the introduction of arts in the hardcore technology, science, and math. And you can see this is the 2006 Libyan eclipse expedition. Often I have been the only woman. This is a sun climate workshop, the first of its kind in 2003. Thank God Judith Lin was there. So I cannot say I was all alone, but this just has been our life. But we are trying to change some of that with the Heliophysics summer school, with the selection of Eddy Fellows, with Eddy Symposium. We are almost getting to 50-50, level of men and women, and diversity in all different ways. I just don't look at gender, race as the only diversity. So through life from joining NASA headquarters now in 1998 to solar cycles ago, my entire journey has been fueled by my core love for the sun, taking me in pursuit of understanding space weather and space climate and making everyone aware of the importance of heliophysics. I've devoted a significant amount of time to education and outreach. So today, studying heliophysics isn't just a choice anymore. It's a necessity, just like we study, Earth, weather, and planet Earth. Now, I came to headquarters to do stereo mission, and along that time, created the SH community, the solar and heliophysics community. And this is kind of my bosses were not too thrilled about it, but I convinced them, just like I had convinced my father that I needed to do science. And so what did we do? We purchased the high energy outer heliosphere component from astrophysics for $1 million, I think back in 2001 or 2. And look at the set of mission and the community that this has created. This is extraordinary. I mean, who gets a chance in one's lifetime to witness things like this? One of my proudest achievements is living with a star. Obviously, you all know about that. Living with a star, first of all, a beautiful name from a NASA science program that was coined by Dr. Bill Wagner, who is no longer with us. And it was started to help astro and space physicists understand space weather better, literally. Around that time, that was the goal. And I was the lead program scientist for this pioneering project, which emphasized the importance of studying the influence of sun on our life and society. And there had been many missions. What makes me really sort of proud as the SDO program scientist for the past 2 decades, I cannot imagine a better outreach platform to reach everyone in the US and globally than these forever stamps from the US Postal Service. So there have been some really extraordinary things happening.
Plus, a new NASA mission to visit and study the sun closer than ever before is officially underway. The spacecraft will plunge directly into the sun's atmosphere at approximately 4 million miles from the surface into a region no other spacecraft has ever encountered.
NASA's daring plan to visit our nearest star, the sun, took a giant leap today. We just announced a selection investigation. These are science instruments for 5 different kinds of investigation for this mission called Solar Probe Plus that's going to visit the sun as no other spacecraft has done before. It's going to go within 9.5 solar radii of the sun. That's about 4 million miles from the surface of the sun. Very close. This spacecraft is actually going to go there and sample the plasma. It's like tasting, touching, smelling the environment of the sun. The line of sight from the sun to Earth is 93 million miles. So there's a lot of stuff in there. You have to detangle that. With Solar Probe, we don't have to detangle anything because it is going to be in that environment and actually measure this with its instrument sensors. So there is a deep connection between what happens on the sun on a normal quiet day to what happens on the sun on a very active stormy day that is directly connected to our lifestyle here on this planet. So we really want to understand what goes on the sun. We want to understand the physics. And with that knowledge, we expect that we will be able to make better prediction so that we can take mitigating steps when some of these storms happen. This is the closest mission to my heart. And I found this video and I thought, oh my God, I have to show this. A lot younger in that picture. And of course, we have hardly sort of unraveled the science of, Parker Solar Probe. There's so much. So I'm getting close to the end. I want to go back. We are transient beings, all of us. Since the universe resides within us, it is transient as well. Almost all of the cells in our body die within weeks to years and are replaced by new generations constantly. The human body and the universe in general is like the ocean and the beach. The cycles of continual ocean waves hitting the shore and drawing away symbolize the decay and renewal as seen throughout the world around us, in the biosphere, in the evolution of continents, and in the lives of stars. This hierarchy of cycles makes the question, how old are you, unanswerable. What are we really? Are we even the same from a minute ago? Much in our body is replaced, recycled, and in flux over our lifetime. Billions of cells die each day, and roughly the same number are created in cycles that continue throughout life. On a regular basis, stardust from the cosmos passes through us, forming successive generations of stars and planets in the same way as it does cells in our bodies, molding and remolding us over and over. Where do we come from and where we are headed indeed? So, through life, death, hope, and happiness, we try to divide ourselves far too much, not realizing that we are inside all of us, living stars. And I kid you not. You are all living stars, and never forget that. Each one of you have star power in you. Use it. This is kind of, I wanted to bring a closure to why did I title my talk Living Stars. And what I want to do, my next slide, is a song. It's a spiritual song written by Tagore, my most favorite poet, philosopher. And after that, we can go to questions, and I'm going to play that. Agunir Parushmuni Choa Prane E Jiban Punno Karo E Jiban Punno Karo E Jiban Punno Karo E Jiban Punno Karo Dahun Dane Aguner Parushmuni Choa Prane আমার এই দেহ খানি তুলে ধরো তোমার ওই দেবালয়ে প্রদীপ করো আমার এই দেহ খানি তুলে ধরো তোমার ওই দেবালয়ে প্রদীপ করো নিশিদিন আলোক শিখা জ্বলকানে আগুনের পরশমণি ছোঁয়া প্রাণে এ জীবন পূর্ণ করো আধারের গায়ে গায়ে পরস্তাপ সারা রাত ফোটাক তারা নব নব আধারের গায়ে গায়ে পরস্তাপ সারা রাত ফোটাক তারা নব নব নয়নের দৃষ্টি হতে খুঁজবে কালো যেখানে পড়বে সেথায় দেখবে আলো নয়নের দৃষ্টি হতে ঘুচবে কালো যেখানে পড়বে সেথায় দেখবে আলো ব্যথা মোর উঠবে জ্বলে ঊর্ধ্বপানে আগুনের পরশমণি ছোঁয়া প্রাণে এ জীবন পূর্ণ করো এ জীবন পূর্ণ করো এ জীবন পূর্ণ করো Thank you so much.
Wonderful, Lika. What a beautiful. Is it you singing?
Yes.
Yes, yes. Beautiful, beautiful, beautiful. I took a screenshot so I can read it again. It's beautiful. Beautiful, beautiful, beautiful. Anyway, okay, let's open for question. What an inspiring talk. So much wisdom in it. Abby, I see, has some questions. And Abby, you want to maybe unmute yourself and ask them and others if you have.
Oh, I didn't think I could unmute. Yes, thank you. Can you hear me?
Yes, yes.
Oh, great. Thank you for that, Lika. That was wonderful. Really enjoyed it. I was wondering if you would talk a little bit more about how you think we're preserving the history of what we've learned in space physics in general, and if are we doing the best job we can at capturing some of the lessons learned and the heritage that got us to where we are?
We are trying. I cannot say that this is the best effort we can do. I think in the last 10 years, there have been significant amount of changes, right? And not just in our community, everywhere. The baby boomers are retiring, right? All my colleagues primarily have retired and new people are coming in. So there's one thing that we sort of missed out on training the next mid-career generation. So what we have, like a delta function, after the baby boomers are gone, we have a lot of young people. And teaching history is very important, but there aren't a lot of people available kind of paying attention to that. But I think you raise a really important point. It is important that we carry, our legacy, how we came to where we are, and where are we going to go in future. Thank you.
Yeah, thank you. Because I feel like this is one of the few places that I really hear people talking about the human story, and I worry a little bit that without people like you, we'd be forgetting that. And I do agree. I think we could do better.
I see that there is Osset at 10, but there was somebody before, probably, I don't know, maybe Nick, you followed in order.
Ray-Jean had their hand up, and so I've allowed them to unmute, and then John Cooper.
Yeah. Good.
So Ray-Jean, you should be able to unmute. Oh, okay. Never mind, Ray-Jean. Thank you. So John, you should be able to unmute.
Okay, thank you. Can you hear me?
Yes.
Okay, great. Hi, Lika.
Hi.
Your image with the background of the total solar eclipse. Of course, we have a big eclipse coming up next year, so that's a big deal for heliophysics. Can you talk about the significance of the moon, as a part of heliophysics and as sort of like a tool for heliophysics?
Absolutely. I could talk about the moon and some of the other planets too. We are a solar system, right? Everything counts. And the moon for our planet is vital. I think everything would be different a lot, if we didn't have the moon. And for the eclipse, what the moon has done, and I don't think that there are that many planets we know where a satellite from a planet blocks the sun just the right amount to create the, effect of the total solar eclipse, the corona. It's not an effect, it's a real thing. The escaping outer atmosphere of the sun. And a life form at the same time on this planet that can appreciate its beauty and delve into its science. I mean, it is the corona from which we eventually figured out, right, that the corona is much hotter than the photosphere, the surface of the sun. And so we have to think of a mission like Parker Solar Probe, that we have to go there to figure out what really is happening. How is this non-thermodynamic equilibrium working? But moon has many other things it has given us. During a total solar eclipse, for example, when you see the diamond ring, that is the last sort of ray of sunlight going through the valleys in the moon. And with LRO, we have done such an amazing job of creating the topography of the lunar surface that now we can use LRO topography, a handheld iPhone. This is actually a citizen science topic for this eclipse called Skyscatcher. I think it's brilliant. And they are going to capture these Bailey's beads from different places, and everything is coordinated, right? We know exactly where this is being watched from, and we have incredible resolution from LRO. So from that data, by using assimilative model, AI, ML tools, and techniques, scientists are actually going to create we hope, an order of magnitude better solar diameter and shape of the sun. And there's just so much, John. That's another talk.
Absolutely. Thank you.
Nick, I have a question, but I would like to first, there's another person before me.
I don't think so.
Okay, great. Lika, I would like to ask you also what you're involved right now and your plans for yourself for the future, if you can elaborate a little bit. You didn't touch on that.
Well, yes. Thank you for asking. So I think, I took kind of like a sabbatical for a civil servant. It's called a detail. And I went to NASA Ames between sort of part of 2015. And then I came back during COVID. So spent about, 3.5 to 4 years at NASA Ames to really engage in the Silicon Valley way of public-private partnership. And while there, I came into artificial intelligence and machine learning and created a program called Frontier Development Lab. That is the future. So over the last 6-7 years, we've been supporting them. There's a small amount of funding. So think about how Living with the Stars science started, targeted research and technology started, right? So these are all small amount of funding that brings together young people. So early career domain experts, early career machine learning experts. And I was funding kind of a broad portfolio, heliophysics and interdisciplinary science. And the results are just, and then they do this work over 2 months in summer. So 8 weeks basically. And the partnership is with the Silicon Valley, commercial sector, like Google, like NVIDIA, like IBM, and they provide us with compute time, which is very expensive. To do this kind of work, you need a lot of compute horsepower. And so the partnership is not for a rocket with these big companies, but for enabling utilization of our vast amount of data and creating, discovery science as well as predictive tools. That's what I'm really engaged in.
Fascinating. Folks, we only have 4 more minutes. So I will try to there was a question by Olga, by Elena. I'm saying maybe we can go quickly. There's a lot of people asking about interdisciplinary science, and you're one of the drive of that. Olga, you want to ask?
Yes, please. Lika, thank you for the wonderful presentation. And I see how your vision was shaped by the Indian philosophy and spiritual practices. When I was a student, we had mandatory subjects in university, which were history of science and history of physics. And in PhD years, it was philosophy on the level of a philosophical department. So I found it was very important to shape scientists, especially young scientists, to make them study all the subjects. So I was wondering if you can add maybe this to, so you created this heliophysics book series and this initiative. Maybe you can suggest some people, I don't know, to do the same for history of science and for philosophy.
That's such a beautiful comment, Olga. I would suggest to begin with that you and Abigail talk, because she's kind of was asking, something similar, and how science is shaped in culture, the language of science. I know, Merav, you like to talk about.
I would love to participate.
I'll give you just one
example. On my mind. Yes.
So you talked about the next series is going to be queer scientists. Well, I am a queer scientist who is married to a man. The word queer, when I came to this country, was just ordinary queer, interesting, different, right?
Lika,
we had all the time.
Lika, we had in phase one a seminar that was based on Tom Krimidis. We had Elena Povornikova, and we have Parisa Mustafavi talking about, because this is also very close to my heart, where you bring a different cultural experience. It's a different eye. It's a diversity. Yeah, that is. I am very keen to what Olga is saying, bringing the cultural background and expanding it, the art and the history. Yeah.
Well, you guys talk about it, and I'd be happy to engage.
I think it's a topic that is not spoken much, and it's critical for how you creatively do science. I very close to my heart. We are almost to the end. Yes.
Yeah, Marav, I missed a person. I missed somebody who had their hand up. I apologize.
Oh, yeah. Okay, last question. It's all set?
All set.
Okay, great. Please ask and yeah.
Here to the eye. So I wanted to ask, in relation to when the moon obscured the light of the sun during a solar eclipse, when it gets dark. So this is also when we have the sunset, when the moon also obscures the light of the sun, and the sun goes into darkness. I want to know, does the moon flips on its opaque side?
No. So the way sunset happens, that's a 24-hour phenomenon, right? The Earth is rotating and we are getting sunset, right? One side is day, one side is night. With the moon during a total solar eclipse, what happens is it comes between the sun and Earth. Now, moon is a lot closer to us and a lot smaller in size, but in the sky, its dimension is such that it can fully obscure the solar disk. And this doesn't happen during every new moon because, the moon is facing us and it's the moon's shadow on us that creates the eclipse. Now, this happens about every 18 months or so because the three objects, sun, moon, and Earth, are in perfect alignment. They are in the same plane. So it's a different phenomenon.
People, I super inspired. We need to close up. We are running out of time. And I can tell Lika, this can expand in many, many other directions. Thank you so much. And on the chat, we were just talking about, we should talk about another webinar that involved art or other cultural experiences. I will absolutely love it. Thank you so much, folks. And I hope to see you next time. And send me, Nick, Sanlin, the Shield Outreach ideas and suggestions for our webinar. This is a forum for all of us to discuss how to do science. Thanks a lot
for putting this together.
Yeah, it was absolutely lovely, Lika. I keep hearing your voice singing. It's absolutely lovely. Okay, bye, folks.
Bye.
Thank you. It was wonderful. Bye-bye.